Okay, now let's take a look at how to do plots in Python. Okay, so now I'm opening the Spider IDE. Okay, it should be open now. If you recall, we already tried to plot the sine function using this script. So first we have to import the libraries that we need, and then I use the variable maxval to assign the range for the variable t. So that's from negative maxval to maxval. But if I want to include, of course, if I want to include the maxval, the positive maxval, I have to add plus 0.1 here, so that it goes from minus maxval to maxval. Because if I don't have this, then it goes from negative maxval to maxval minus 0.1, because maxval is not included. Then I use this command in order to get the sign of t and then assign the values to the variable y. And in order to plot this, of course, this is something's missing here. plt dot plot. Okay, that should be, and we should tell Python what to plot. Okay, so that should be pretty much it. And we should be able to see the plots, our plot here. And okay, let's run this. Okay, so now we see our plot function. So what can we do here? Okay, first let's play around with the line. Okay, so let's change the line width. So the line width, the default is, I think it's 1 or 0.5. It's the same as in MATLAB, so let's try 3 here. So yeah, 3. Okay, so I press this. Okay, yeah, so now it's a bit thicker. So I can change the color. Okay, equals, the default is blue, so I can change this to black. Black is K. Okay, now I have that. I can also change the line style. So line style equals, let's say a dash and dot. Okay, for the sine function. Okay, so we also have that as well. Okay. Okay. So what else do we want to do? We would like to add a title. plt.title. So here we have this is a sine function for the title. I can also change the font size. So font size equals, let's say, 16. I think the default is 10. Okay, so now there you have it. There you have the title. You can just add the dot there. Okay, I can add labels, plt.x label. Okay, let's say omega, and the units in radians, and the same for the y label. Okay, then I can add amplitude, and we have arbitrary units. Okay, then click play here. Okay, and then I have those. Of course, I can also change the font size. It's easier if we just simply copy this. So I'll choose a smaller font size for the, say 12 for the labels, X and Y labels. Okay, so there. Okay, so is it a bit, yeah, it's a bit clearer now. And of course, omega is a Greek symbol, and this is how you type a Greek symbol in Python. So open close parenthesis, and then backslash, and then omega. Pretty much the same as in MATLAB. Okay. Oh, this is, no, sorry, it's not the same as in MATLAB, but instead I use a dollar sign backslash, and terminate this with a dollar sign as well. So now that should work. Okay, there we have it. I forgot the closing parenthesis for radians. Okay, what if you want to change the figure size? I have to put the figure size here, plt dot figure, open close parenthesis, fig size, and then equals, do the default 4 by 3. Okay. Okay, so now it's doing 4 by 3. It's set to 4 by 3. If we set it for 12 by 9, this is 12 by 9, and then if we double this, 24 by 18, for example, then we have 24 by 18. You can see that it increases in size. Now the placing of this is quite important. If I remove this here and I put it after the plot, okay, what it does is, okay, first it plots this and then it resizes the plot. But upon resizing, you lose the data that is inside the plot. So you have to, again, like I said, you have to do it in the correct order. So, which means that in Python, the figure, this figure command comes in before the plot command. Okay, so that if we play that back, we have this fig size. Okay, so let's do a 4 by 3 so that the data is easily seen. Okay, what if we want to add another data point? Okay, or data set. Let's try z is equal to np.cosine of t. Okay, then what do? So what I'm going to do is just copy this, then paste it next to it, after it, and then change the parameter from y to z. Okay, and also like to change the color, red. Let's do blue here. Okay. Okay, so now I have blue for the sine function and red for the cosine function. Of course, I have to change the title because these are now the cosine and cosine functions. These are the sine and cosine functions. We have to be grammatically correct, don't we? Okay. Of course, you don't, contrary to MATLAB, in MATLAB you need to use the command hold, but here you don't need to do that. It automatically plots it in this same graph. So what if you want to add legend? So type in pld.legend, open close parenthesis, open close square brackets, and then type in the first one, which is the sine, and then the second one, which is the cosine, and then we press run. Okay, you should be able to see, yeah, there it is. Okay, and it's in the middle, and you don't want that, you want it to be somewhere. So type in loc for the location, and then let's say upper right. Okay, there we have it in the upper right corner. Okay, so you notice that as we are editing these figures, we see all of the figures down here. Okay, so we can easily go back to our original figure if you want. Okay, and then just save it if you want. You can save it like this, so you don't have to do Control Z or undo because Python already saves all the figures here. Okay. So the next thing that we need to do is to save it. So plt dot save fig. Okay, and then open close parenthesis. Okay. Okay. Now, how do we save this figure? Okay, we use this command save fig. We need the file name, but before we write the file name, we need a directory. And if you go up here to the upper right corner, okay, this is your working directory, and it will automatically save the file in this directory. So if I want to save it somewhere else, let's say in another folder, I click that folder button there. I go to the folder that I want to save it in. Okay, so this is in week 1, and I want to save it in Python codes, and just select open there, and now it will automatically save in that folder. Okay, I write the file name, so sine cos. Okay, the default is PNG, but you can choose other types of figure names. Okay, so you can also type in the resolution. So let's have a resolution of 600 dpi. Okay, so that should be it. So okay, so let's go to the directory to see if it's there. So here's the directory. It's actually here. Okay, so now I have this. Okay, so you have to, of course, when you do all this, you have to figure out the correct sizes. Otherwise, you're gonna end up with this. The titles are out of place. You don't see the Y label. You also see the X label partially. So you're gonna have to figure out how to resize the figure. Okay, one last thing. If you need help in any of these commands, figure, plot, title, X label, legend, it's all in the Matplotlib. Okay, I already gave you the link for this. If you go back to Kaggle or UPB VLE, and then you go back to this course, computational physics, scroll down, and you should be able to see the link somewhere here, just after how to download and install. Here, other resources related to MATLAB and Python. Click this one, okay, and type in whatever you need to type in there. Type in plot, for example. Okay. So here's the Matplotlib. Okay, and then here's the syntax for the plot. But if you scroll down further, you can see the various commands here, and the plot somewhere here, there. And then if you click that one, then it will show the syntax for the plot function. Okay, it's a bit too technical, but here you can see X, Y, and then G is for green, O is for the marker size, a double dash if you want to use a double dash. So it's pretty much the same as in MATLAB. Line width equals 2, marker size equals 12. Just like in MATLAB, but in MATLAB you have to put open close single quotation here. Okay, line style, line width, okay, that's very much the same. Okay, so if you want to do the other, look for the other commands like figure or save fig, for example. Save fig. Okay, let's do that instead. Okay, here, should be here. Okay, the save fig is here. So fname, that's the file name, the DPI, which is what we set to 600. The face color is W. It's just the color of the background when you save it. The edge color orientation, and so on and so forth. So you can do a lot of things, but you're gonna need to look at the help or these help documentation for these functions. Okay, so that's it for the Python plotting in Python.